Hello, everybody. Good morning. Welcome back to the Alan Turing Room, final day of the Matrix conference. Today, to talk to you about solving the fork dilemma, from Connect to X, we have Michael Thiele. Please, big round of applause.
Yeah, thank you. Like you said, I'm Michael. I'm from Connect to X, and we at Connect to X, we think we solved the fork dilemma. And there's a subtitle here, how we build a maintainable matrix messenger, and it's already wrong. I noticed now because that maybe there are lots of mistakes on these slides. This is the first one. We don't build a matrix messenger, we build multiple matrix messengers. So the forking dilemma, if you just build one messenger, maybe it's not that complicated. But if you build multiple messengers, then maybe it is. So let me start asking the audience, who's a developer here? Okay, the majority. That's good. It's a development topic, but it's also a business topic. So how many business people are here? Okay. Okay, some. Okay. I think my talk is like a connection of both worlds, so maybe the developers will find some topics uneasy, and also the product managers, but hopefully we all can agree in the end on something. So imagine you work in a company and then you have a boss, angry boss, it seems, and he's like, we need a messenger. And since we are at a matrix conference, I assume you all say, well, of course, we built a matrix messenger. But where do you start? So developers, when they hear something like, oh, we can build something new, it's like, yeah, all of the synapses are firing in your brain, and you're like, greenfield, wonderful. Oh, it's so nice. I like nature. I like green, and greenfield sounds really, really nice. But there are lots of buts in my talks today. But writing a matrix client is hard. So if you start from scratch, if you say, well, we have the matrix protocol, we can build on that, we can build a messenger on top, and you try to naively implement a matrix client on top, you quickly realize that there are a lot of hard problems. So, for example, timeline and room management, and also the protocol. You have to have some kind of programming language that you interact with the protocol. And so lots and lots of hard problems. Also, the whole encryption, decryption issues. So you don't want to do that on your own. So what could you do? Just ask. Fork is, yeah, that's one. I'm not there yet, but a really good idea, but maybe a step beforehand. An SDK, yeah, right. SDKs to the rescue. So you have lots of SDKs in the Matrix universe. You have the Rust SDK, Dart, Trixnity for Kotlin. So you could use an SDK that does all the nitty-gritty details, like the machine room here. It preserves the timeline, it does all the encryption and decryption stuff, and it's great, because it helps you tremendously. And then you can write your matrix client. You take an SDK in the language of your choice, or maybe some features you need, and then you build a matrix messenger on top. But, there's again a but. It turns out UI is hard too. For a messenger, if you just build a prototype and it has to work and has a bit of timeline and so on, yeah, you can build this in 1 week. Maybe if it has to be a little bit polished, a month. But to build a really good messenger that really feels like a messenger you use from big companies. We know what the other companies are and what their messengers are called, and they have lots of fancy features. They don't look like much, but if you try to implement them, it turns out it's really hard too. So yeah, wouldn't it be great? Because in the Matrix ecosystem, we have lots of Matrix clients already. We have lots of UIs and also very polished UIs and very good working UIs. Wouldn't it be great to use those messengers and those UIs? And maybe our boss, I didn't tell you, he was like, well, we work in a special domain. Maybe it's law, government, healthcare, whatever. We need a messenger that has like all the basic features, but we need some bells and whistles on top. And to do that, you could do the fork. So to summarize, and I like pictures, I like drawings to make a point. So to summarize the approaches, here we have the naive approach. You just take the matrix protocol and you build a messenger UI on top. And I would say that's a big no-no. You can do it, but with all the multi-platform SDKs around, I would say choose one and go with it. So yeah, the next iteration was like, we have the matrix protocol, but we have an SDK on top. It takes a lot of work from our plate, and then we have the UI on top, and that's fine. And there are use cases where this is really helpful and it's really good. So you can write messengers like that. And I would say, yeah, gets a check. Maybe a bit yellowish because, yeah, you have to do a lot of work. And like I said, UI is hard. But you could do it and it's totally fine. Or the last approach, I was not talking about forking yet here. We take an existing messenger UI and then we extend it with our own implementation for like our domain, healthcare or whatever. So we have, for example, an element client, and then we put some buttons in it and extend it and maybe change some behavior. So that's the thing I would say. If you can do it, go for it. But the question remains, how can you extend an existing messenger UI? So, like someone suggested, so it's no surprise here, let's fork. That's really great. It's the easiest solution. It's very simple. In a matrix ecosystem, lots of messengers are open source. So it's no problem. You go to GitHub, GitLab, whatever. You just say fork, and then you have your messenger. Perfect. But there's always a but. So what is a fork? A fork is like a copy of the original that still has some connection to the original. I call it upstream here. So there are changes that are happening in the source after you started your copy, and you still have a connection to your source code. So for example, in the source, we have a circle that is yellow, and in our fork, we turned the circle blue. Perfect. But then another enemy arrives, and this enemy is time. So time goes on, and the source changes. So it's not a circle anymore, it's a square. But we made a circle, and it's still blue. And we want blue, but maybe the circle is outdated. Maybe we should do a square, I don't know. Are we still upstream? I'm not sure. No, not yet. So what can you do in this moment? Well, you have two options. You can just ignore it. You say, well, I don't care. The connection is severed, and then you have kind of a copy. You do not have a fork anymore. It's more like a copy because the upstream is severed, and you're done. And then if the source changes again, and it's a square, but it's maybe rotated, you don't care. You still have your blue circle. Or what you should do, because you're forking, is to adapt to the changes from the source. So you still have upstream, and you can do this at any moment. So you can do it as soon as the source changes. You can go to this, or even later if it changed 3 times, you can still at some point invest all the energy and do the upstream changes. And then you arrive at this point, source and your fork are in sync again. So I hope everyone agrees on this kind of model. Yeah. So this comes, like everything in life, comes with some pros and cons. And on the plus side, it's very easy. Like I said, you just go to GitLab, you just clone or fork, and then you're done. You have fast results. You have a messenger that's already working, and your first iteration is like, bam, I can show my PO, my customers, I can show a working messenger, and it's great. Fast results. And then I can build on top of it. And what's really great as a developer, I'm also a developer myself, at least part-time now, you have all the power. Everything that's in the source code is available to you, and you can look into it, you can copy it, you can change it, you can modify it. You have all the power. And this feels great as a developer. And you, with all this power, you also have, like I said before, you have fast results because you can change every screw in the original source. But there's also some cons. Forking, like the original, what happens if there are fixes? Like what I shown on the slides beforehand, if the circle goes to a square. What happens if there are fixes, especially security fixes? If you work in a domain like healthcare or in the military or whatever, it's really important you have SLAs or something like that you deliver security fixes really, really fast. But what happens if those in the source, they change rapidly? And what happens, and this is one of the biggest things that can happen, what happens if there are refactorings in the source code? So your source, your circle is now divided into 5 different files. And maybe the whole logic is rewritten, and you have adopted this logic and changed it, and now you're like, I have to do it now? No, we have features to deliver. And this is the last point. It's like, it's always not the time. Because you're not generating value, not real value, at least in the eyes of the customer, if you just do merge conflicts and try to implement the latest security fixes and try to find out where the refactorings scattered all the code that you were depending on. So, yeah, it is flexible, it's really powerful, but it also has some drawbacks. And then I thought about my university. It was a long time ago, but we had a course where we talked about software architecture, and my prof, he said, well, this is white box extensions. White box, why? Back to school. So what are white box extensions? The developers of the source have no control of what is considered private or public. Everything is visible and everything can be used and can be accessed by the forking party. Because it's open source. Yeah, you have all the source code in the world, and as the source provider, what can you do to prevent someone to fork your code and use this special file that you know, no, they shouldn't touch it because we want to do a refactor in like 3 months, yeah, something like that. Well, you can try to communicate and so on. There are ways around it, but on a conceptual level, nothing can prevent any forking party from accessing any information that you are providing. And that can be dangerous. So since we're back in school, if there are white box extensions, what else could there be? Black box extensions, yes. And also gray box, and there's a lot of subtlety there, and I'm not going into that. I'm not an academic. So we just do them the same. And there it is like the developer can define which part is visible and can be extended. from the source. So you have some kind of control what people that are using your product can use, what they can extend, and what is considered private. And you can imagine it like an API. And if you get it to the point that the API is stable, the better, because then everyone that is extending your product or changing your product, as long as they rely on those stable APIs, on those interfaces or whatever you define as an API, then they're good to go. And every change they're making, as long as it doesn't break the API, it should not break your product. So to put it into like some kind of architectural overview. So we have fork on the left side and extension mechanism on the right side. So on the fork, it's white box. It's a white box source. And on the right, we have the gray box. And the source has some kind of extension points, some API, extension point, whatever you want to call it. I'm not talking about implementations yet, but imagine that there are some holes in the source where you can interact as a developer. And yeah, if you want to do some changes with the forking, you just change whatever you like, for example, the circle. And with the extension, well, you can only access those shapes that are defined there. Everything that's in the gray box here are not allowed to use. But for example, you can do an interface implementation if the white circle is an interface. And well, you can extend this and say, well, I define my own behavior here. Or you can do replacements. So there is already a yellow circle, but you want to change it, and you change it to blue circle. So the same as on the left side, but it's really constricted from the original developer. And if you find this too abstract, I want to show you some code now. And I hope I kind of meant it like a joke, but it's kind of not, because this was like boxes and some high-level concepts, but how does it look like? So I'm going to go into our product, and I tried to come up with some examples that are really, really small. So don't expect too much here. There are lots of more complicated cases we have in our source code, but for understanding, I chose some really, really simple examples. So to understand the context, in Connect to X, we are developing matrix clients, and we're also developing TI Messenger. For the German healthcare, we develop messengers there. And there are lots of new rules for a TI Messenger that are not a matrix messenger. So in our architecture, we have the matrix messenger as a base. And then we can change this matrix messenger and adopt it to the new domain. For example, TI Messenger. So what does it look like? So here we have a TI Messenger, Tim, member list element view model. So we, at some point in our some part in our application, we have a member list. You have a room, you go to room settings, and you see the member list. And I can show you what it looks like here in our matrix messenger. So you go to room settings, and then you have the member list. And every member has a member list element view model that computes what should be displayed here. So we have all the participants in this room rich text test. So for TI Messenger, we have some kind of restrictions or rules for visibility, because in healthcare, organizations are considered, well, a safe space. In your hospital, you can share all the information, but if there's some other party involved, maybe you want to inform the users that you're using the messenger. Well, there is someone of an external party involved. Maybe don't share information that is really sensitive or whatever. So to build this into our messenger, we say, well, we can use our we can use our member list element view model. It's still perfectly valid. We still have a picture. I can show you what the original looks like. So we have a user ID, a member element, a trust level, what's the membership for the room, if I have the power to unban, and so on and so forth. So we have defined an interface that defines what a member list element looks like, what we expect as an UI, for example, for a member list element. And then a UI can display this information. And for the TI messenger, we want to have just one more information in there. Everything else is fine. We also need it, but we want to display if the user is external. And then we implement this interface. We say, well, it's an extension for it. And now we have a TI messenger member list element view model, and it has an external user. And then we define an implementation for it, and this, I can show you it looks into if the member is joined or invited, and if the domain is a different domain from our. Because in TI messengers, organizations are equals to domains, so we can do this trick here. But yeah, this is reusing all the existing logic and using one defined extension point, this interface, and defining something new on it. And then we can use this in our UI to display it. And I can show you in a live demonstration, so hopefully it works. Because I know live demonstrations are always a fun part of a so if you have this TI messenger here, and I can open the same room. There, it's rich text. And you see also in the header, it's like, oh, there are some external members in there. But if we go here into our members list, you see it looks really the same, different color, but yeah. But some members are external and some members are internal, like Benedict and myself. So Benedict and I, we are on the same home server, but everyone else is on another home server. Outside of TI Messenger, it doesn't make sense to do it like that, but just to show you how it works. So we can, on the code level, we can easily extend the features with new features. So we can add new features. We can also say, well, we can change features. So on the SDK level, some behavior from the original Matrix Messenger does not apply in TI Messenger context. The specification for the healthcare messenger has lots of strict rules. For example, who can invite who. And there were also lots of iterations who can invite who. So it's really complicated. But in the room settings, you can invite new members. But there was a rule in TI Messenger that if it was a direct room, you could not invite new members to it. So if you have a room with 2 people and it's a direct room, marked as a direct room, you were not able to invite new people. But we already had a feature for it that has power to invite, so we just override it. So we define the origin is the room settings view model, but we define a TIM room settings view model. You see, there's a pattern there. It's always the same pattern. We just implement some interface. We also see here, oh, it has external members. Yeah, of course, because now I closed it. It was really, really dumb. I will go to this one. because here in the room settings on top is also has to display, or we wanted to display if it's external. So we also have this one, so the extension, but we also have a change of behavior. And in the end, we just use dependency injection to configure our messenger together. And then we say we'll take this part is matrix, original matrix, this part is TI messenger, and then it's like scrambled all together. And then if I start the application, it's a TI messenger. And we did not stop at the logic, because that is something you need. But as you saw, we want to display these external badges also. This is change in UI. So we also had to do changes in UI, and we implemented the same thing. We, like with the view models, where we sliced up our messenger in lots and lots of small parts, where we define logic for this part, logic for this part, logic for this part, and so on. We also sliced up our messenger into different views. And we said, well, we have a room settings view. And if you're not satisfied with the matrix room settings view that we are providing, you can provide your own. For example, Tim room settings view. And then what you can do, you can override how this view looks like. This is not as powerful as the implementation for the SDK, because we cannot reuse code here. So it's a full-in replacement. But still, we tried to make those parts really, really small, so that you can reuse those. So for example, the Tim room settings view has external users. This is not something like in the room settings view, but we use it here. And then we display a UI element if the room has external users. And this is not part of the matrix messenger, it's just part of this specific view for TI messenger. All right. I know lots and lots of code, and it's Kotlin, and you don't know it, but I still wanted to show you like an overview how we do it. So it's just like interfaces, and you can implement those interfaces with your own implementation. And if you need some original logic, you can still use delegation to the original and say, well, the original was not wrong in most of the cases, but in this specific case, I need something special. So, what are the pros and cons of this one? Because we also thought about, well, is this better or is it worse than the other approach? Well, on the pro side, if you have stable APIs, your changes from the original, it's just like you update your version number. You are depending on the matrix messenger 3.8.1, and you want to update, you update to 3.9, and everything should work out of the box because the APIs are stable. What we saw with the view models and the view, those are considered stable from our side. You can also reuse existing logic, which is something in the fork you also can do, but you have to invest a lot of work to not get so many merge conflicts, to reuse logic from the original and to define your extensions that are not in the way of the source code. And you're still flexible. Like I've shown you, we have tried to slice up the messenger in really, really small parts. So you only have to change the part that you're interested in and not the whole messenger itself. But still, nothing in life is free. There are some cons. You have the fixed granularity. So we decided how we slice up the messenger. If you need something more fine granular or maybe broader, then you have to work a little bit around it. And like I said to you, in the view we have only replacements. We have not yet come up with a solution how to reuse some parts of the original UI part that you're replacing. So it's just a replacement. And what we really noticed is the learning curve is really steep for people new to Kotlin and dependency injection, and also the whole concept is like a bit strange for most people. And it's okay. I know we We don't see it at ConnectorX because we developed it, but I know it can be a hurdle. So with forking, it's like you start, go, and then you have some results. And with this, it's like, oh my God, I have to read some document. Oh, how does this work? And what can I extend now? And how do I do the configuration? It's a little bit of a hassle, but if you get into it, the pattern I've shown you with these interfaces are still, we try to implement it everywhere the same. So if you understand it at one point, you understand it at every other point. So this is what our architecture looks like. I just don't want to go into much detail here, but this is what the SDK level looks like. This is Trixnity. It's like I said, like Rust SDK. So this is only a small part of our framework. Then on top we have Trixnity Messenger, which is another extension that I didn't mention here, which is all the view models. It's like the SDK, but doing it for a view and deriving all the data that a view needs for a messenger. Because Trixnity and also Rust SDK, they do matrix protocol, but matrix protocol can be anything. It can be a messenger, but it can be anything, and they need to be flexible. I understand, but if you want to build a messenger, you need maybe some more some higher level extensions on it. And then we have one example for us is like TI Messenger. So we have Tim extensions, and we also have Tim extensions in multiple flavors. Don't want to go into details, but this part here, this is the extension. So Trixnity Messenger defines the interfaces, defines default implementations, and the blue square, the Tim extensions, they only define extensions on top of it. And then we have the UI part. We have Trixnity Messenger UI, which is in Compose multiplatform, and you can white label it, and we have a white label client called Tammy. That was the green messenger I've shown before in the example. So Tammy is a matrix messenger, just a normal matrix messenger, but underlying is a architecture that allows people to take this messenger and put own extensions on top of it. So on the UI side, you can also extend this Trixnity Messenger UI, and you get your Tim extensions UI, or your government extensions UI, or whatever domain you're working in. And then you can also white label it, and for TI Messenger, we have Timmy. And the user only sees this white label messenger, don't care for all the architecture behind. But in development, I think this can be helpful. So if you take all these approaches, and I tried to make it that those are really new. It was like I talked to somebody yesterday in the evening, and I had this idea. So this is really hot from the oven. So if we talk about value over time, if we take all those different approaches, if you take the SDK approach, like Rust SDK or Trixnity or whatever, and at the beginning you have zero value. If your boss comes to you and say, we need a messenger for the government, you have zero value because there's no messenger that you can show. There's nothing what you can present. But I don't know if it's linear, but maybe assume that it's linear. Over time, you create value, and you create a messenger UI, and then it gets better and better and better. And then, yeah, at some point, you have created some value, and it's a messenger that's working, and it's working for your domain. Perfect. Then we have our extension with the view models, which are higher extensions for messengers. And then there you have you also start by value 0 because still no messenger in sight. But UI can be built a lot faster because everything is there. You just need to adopt to the view models, and then everything you need is there, and you have a quick jump start, and then it's like also linear. So maybe the progress is even better, and you have more value. And if you use the view extension mechanism, you already at point 0 in time, you already have value created because you already have a messenger. You can show your boss, well, this is what the messenger looks like. Well, it does not have all the extensions and all the bells and whistles that the government needs for their special messenger, but it's still a matrix messenger. So, yeah, when you say, well, we can build this, and maybe it's also linear time, you can add and add more features that are satisfying the needs of your customer. And then we have the fork, and now this is maybe a bit controversial. Looks maybe a bit like this. The start is maybe a bit quicker because, yeah, as I said, the learning curve for the view extensions, it's like a bit harder. You're quicker with the fork in the beginning, but then you have those plateaus in between where you don't generate value. These are the times where you have to sync your source to your current implementation. And maybe if you do not change much and so on, and you have established patterns that are really well suited, maybe those timeframes are not as long, but still you have a kind of a plateau, and then you can create value again, and then you have a plateau again. But it's not only upstream changes, also downstream changes where you implement a feature where you say, well, it could be really well suited for the original, so maybe we can backport it, and then you have also some workflow there. So maybe over time you still have lots of value. I don't want to argue against forks. It's perfectly fine. But we believe that over time, a fork will slow you more and more down, because if you try to imagine this timeline goes on and on and on, and you have 1 year, 2 years, and maybe 5 years, the changes from the source to your code, they will get bigger and bigger and bigger, and also the merge conflicts and things that do not fit well, they also will grow and grow over time. So you will be slowed down even more. And with the extension mechanism, well, since everything is stable or considered stable, you should be fine. So, yeah, maybe we should rethink how we build matrix clients. And the image I came up with is maybe we could choose it as a library. So matrix messenger UI, matrix client is maybe like libraries. I like this, I like this, I like this, but then like a library, I extend it, and maybe I adjust it to my needs. So that was my talk. So Tammy is our open source matrix messenger, which is the base and the foundation for everything we do. Trixity Messenger is like the thing everything builds on is open source. You can visit it on GitLab. And yeah, we are Connect2X. We are developing those, and I'm open for questions.
Thank you very much. Please raise your hand if you have a question.
So it's a question and a comment. You forgot one important part in that. I've built tons of really complex enterprise scale solutions like that. You forget the complexity.
Yep. Oh.
There's a massive part in complexity in both the framework or whatever, the library you're using, as well as in the applications that use it. And the decision is always, what do I put in the core? What do I put in the extension and so on? So the question is, the trick and the forks also, I would say, you think the API is stable over time? I've had 15-year running projects. The API is not stable over time. Spring is also a good example. It changes over time.
Yep,
and you have to adapt. So you will have the same patterns that you have in frameworks. So the question is always, when do I fork? When do I do an extension?
Yep.
And when do I change?
Yes. Yeah, you're right. APIs can change, and they will change. Like you said, Spring Framework is also claiming that they have really stable APIs, but then they have a major version update, and then you change some things. And you have to adapt. So you also have some kind of plateau there. You're absolutely right. But I would argue in the meantime, when you need security fixes and so on. So you're working in a constricted environment and you have SLAs and some sort of that. It's really easy to be on a stable version and to just get those updates for free and do not have to have the hassle with the okay, now I have to do the merge with the fork. So you have more control over when it happens, because you can always decide, no, we want to change the next major version in like 3 months, or maybe we wait until next year or something like that. But a fork, they always they push it onto you at a moment that can be really unforgiving for your project.
So another comment, not a question, from someone who is a big fork. And I agree with a lot of things you're saying. Forking is hard and refactorings are the work of the devil. But I think for on the one hand, you are missing a little bit of the pros that being a fork has. Because when you are having your downtime, merging, you are creating value in a way because your FOSS is making stuff that's interesting for you. You get spaces, threads in our case. And I think having the security fixes, the open source product provides is a pro in a way too. But you are right, having those at an inopportune moment in time, like, for example, Room version 12 was, is difficult too. And on the other hand, I find it interesting that we are managing our fork very similar to you are using your extension. So we are overwriting the views completely if we need to. Yep. We are extending our view models. So being a fork requires a lot of mental energy to do it right. And then you have the learning curve. So you have the disadvantage of having that. But you can make it easier on yourself on the long run for your mergers and for your handling of the force. So it's always something where being a fork or being a large fork is at some time very similar to what you are doing.
Yes, but one thing maybe is a problem that you have to invent this architecture for yourself.
That's right.
We are providing an architecture which you can use. I also said, well, it's complicated to use for newcomers. That's always a thing with those frameworks, but I think coming up with an architecture to make a fork work is also very hard. And I think one of the advantages of our model is that we kind of took that at least some of the hard work from you, and we said, well, okay, you can rely on this architecture and build on top of it without thinking too much about the architecture.
I agree with that. Up to the point when you want to do something that's not part of the API.
Yes.
But hopefully most of us won't have to do that.
We try to make everything really, really flexible. But we also had some struggles with things where the API was not powerful enough, so we had to adapt. But thankfully, the changes were not breaking for the API, so it was more additions to the API, new fields or new members introduced, but it did not break any existing clients.
Yeah, thanks.
Okay, we have a question from the Matrix room. If I want to make a messenger with a few extra features, which project should I fork, Tammy or Trixnity Messenger?
You should use Trixnity Messenger. Tammy is just the white labeling for the messenger, but you can use Trixnity Messenger as a library. So you just include it and you say Trixnity Messenger in version 3.8 or something like that we are currently in. You include it into your project, and then you can write your own extensions or your own UI on top of it.
And then from the same person, if I want to implement unstable MSCs, do I have to start the forking process from the SDK layer?
That maybe depends on how deep the MSC changes are. So, for example, we had to implement dehydrated devices, which go deep into the SDK layer. So it was implemented in Trixity. But I can imagine for some MSCs that are more on the view layer and presenting information that you can implement those with our approach, yes.
I'd also remind people that this is also an open source project, so if you want to extend the underlying layer, you can contribute that as a PR upstream and work with your upstream. One more question. Oh, this is actually a question about forking element, so maybe I won't ask that one. Yeah, one moment.
Thank you. I really like the approach, but I wonder, doesn't this make potential... I don't see merge conflicts as bad necessarily.
Yep, sure.
I think it's good to have them because it's an opportunity for you to really tell what you really need in your product from the source,
yep,
and what you don't really want. And I'm a bit afraid with this approach that you won't get that opportunity. You will
yes,
be more trusting that the APIs don't change, that it's stable. But then you realize when you run your project after doing an update, yeah, I have extra stuff going on that maybe I didn't need.
Yes. So one way to prevent that is, at least on the SDK level, you can write unit tests for it, because view models don't need a UI, so you can write simple unit tests to test your logic. And if you reuse some logic from our view models, for example, you implicitly test this with your assumptions, and if the tests are read, then you know, okay, something in the underlying framework has changed that we assumed were like X, but now it's Y, and you can look into the source code because it's also open source. The other point, how do I get informed about changes that maybe affect me? That's a very interesting question, because I hope that in 95% of the time you don't need to be, but the rest, the last 5% where you should be interested in on, we are not sure yet how to do this. We do a change log where you see everything that changed, but we don't write, okay, we changed this file and so on. So it's not as detailed as maybe you get when you do a manual merge request. So we are still struggling a bit how to do it on the right level. Too abstract or maybe too low level and too much details. Yeah, and you can also do a diff yourself from one version to another and see what we have changed. But yeah.
I have a follow-up comment about the topic of forks versus libraries. The rule of thumb that I apply is a fork is short-lived. If not, it's a copy. It's like people are afraid to copy, but sometimes it's the right approach. If you know that you're going to diverge and you are going to probably go a different direction, do a copy. Doesn't mean you can't look at the other side and be like, okay, this looks good, I'll take it over and rework it, whatever. But it's a copy. Be okay with that. If not, you should go the extension mechanism or library or SDK, whatever you call it, because then you get the flexibility. But you have to make that conscious decision.
Yeah, it's not like I was saying, like one approach is better than the other. It's just like we have an alternative to just forking, because like 2 years back when I was at the Matrix conference, everybody was talking about, we forked Element and we're doing this, and we had lots of problems because also with Element there was another point I didn't mention. You had also 3 different platforms you had to reconcile. So you had merge conflicts in web and Android and iOS maybe, and all the platforms worked a bit differently. Here we have one platform for one source for every platform and also the extension mechanism. So we believe this is easier, but yeah, of course, you can also do a copy. And if you only need web, why not use a web client that works really well on the web? Yep.
Okay, I think we have time for one more question.
You talked a lot about forking, and I'm sort of missing the point of communicating with the upstream project.
Yep.
Can you say something about that? Maybe one opportunity, if you want to do changes, is also talk to the upstream project and develop your solution together instead of forking and doing an extra thing.
Yep.
Yes, please say something about that.
Sure. Like I said, I was only looking at the technical aspect of it. But sure, you can build social constructs around those problems, and they can work. They can even work really, really well. Like I said, I'm not arguing against forking. I'm just saying, well, it's one way to do it, and there's another way also that could be possible. So yeah, if you have a good relationship with your source and you have lots of communication, then of course you can communicate lots. You can communicate better. That like refactorings are not something like out of thin air. They appear, but you know, okay, they will refactor this thing X in like 3 months, and we should be prepared. And we also know how they will refactor it. Maybe we influence how the refactoring is done. And you can also do this with the library approach, because this is open source. So you can do merge requests here. You can have feature requests and say, well, I want to do this and that, but I cannot do, or how can I do it? And then we also can come together and work those things out. So I think the social constructs work in both ways. And yeah.
Okay, another round of applause, please.